Reaction time, the time it takes to respond to a situation.
Distractions affect his reaction time, making it more likely for him to wreck. Some of the distractions include turning up the radio. Talking on the phone.
Hello.
And eating.
Second rule. When driving behind a vehicle, pick a landmark. When the car in front of you passes it, start counting. If you get to 3 before you pass the landmark, you are at a safe following distance. This means you would have enough time to react safely. 1, 2, 3.
In this video, we are going to explain and show what following distance and the 3-second rule is and how to use these methods.
Following distance is the distance that you travel behind the car that is in front of you. The 3-second rule is a safe way to figure out if you are the right distance from the car.
The 3-second rule is whenever you have a car in front of you, you pick out an object, such as a mailbox, in front of that car. Then you count in Mississippi seconds how long it takes to pass the mailbox after the car in front of you has passed. 30 seconds or more is the safest time.
Here are some examples of the 3-second rule.
To determine whether these cars are a safe following distance away from each other, you can use the 3-second rule. So when this one drives by the cup, you can count to 3. 1 Mississippi, 2 Mississippi, 3 Mississippi. It took longer than 3 seconds before this car passed the cup, so they are a safe following distance away from each other. The same rule can apply in an unsafe situation. So you can tell these two cars are way too close to each other because they passed the cup in less than 3 seconds. And if this one was to stop suddenly, they would rear-end each other.
You don't have...
We pressed the gas for 28 feet at 6 miles per hour, then traveled 24 more feet before stopping. The total stopping distance is 24 feet.
Again, we traveled 6 miles per hour for 28 feet. We then pressed the brake and traveled an additional 12 feet. The braking distance is 12 feet.
We traveled 28 feet at 6 miles per hour and had a reaction time of 0.7 seconds. Once she saw the person walking in front of her, she slammed on her brakes and traveled 5 more feet.
She was traveling at 2 miles per hour for 28 feet, and then it took her 7 feet to finally stop.
This is Hef Dog, and we are doing our project over intersection. As you'll follow me over here.
What's the intersection?
Can I go?
What?
Explain what an intersection is.
It's when two or more roads cross.
I'll explain to you what factors affect go and stop zones.
The car right here would be in the go zone because it is right up against the light, so it'd be able to go. But this car right here is in the stop zone because it is farther back than the other car, so if it goes, here's what happens. Ooh.
There is. It can rain sometimes and cause less friction on the pavement.
Here are the factors: yellow light time, human reaction time, speed, negative acceleration, and width of intersection.
Alright, so I'm going to ask you some questions. What are the factors?
Well, I already told you. Yellow light time, human reaction time, speed, negative acceleration, and width of intersection.
Do you know what the variables are? Alright, this is the intersection near Cracker Barrel where Lover's Lane meets Highway 53.
Following distance is the minimum amount of safe traveling distance between two cars. A good way to ensure you have a safe following distance is to use the 3-second rule. To use the 3-second rule, you need to pick a landmark such as a road sign or a billboard.
Then after the car in front of you passes the landmark, you have to make sure it takes you 3 seconds to pass it also. If it takes you 3 seconds, then this is a safe following distance. Be aware that the faster you are going, the bigger distance there will be between you and the car in front of you. Likewise, the slower you are going, the smaller the distance there will be between you and the car in front of you.
¡Híjole! ¡Check down! ¡Go!
What are curves? Curves are something that you might encounter every day, but do you know how they work?
Go.
No, you don't.
This car is moving in a circle, which is simulating a car on a curvy road. Do you know what is keeping this car in the circle?
No, you don't.
Go. The string does. It is acting as the centrifugal force in this example. Centrifugal force is what keeps the car moving in a circle. If we let go of the string, we don't have any centrifugal force, which causes the car to go in a straight line.
On real roads, the newness of tires, roads, weather conditions, and brakes affect the friction, which determines how well you can drive on curves.
Go.
Go. Acceleration equals velocity divided by time. This means that acceleration is happening anytime you are moving and or changing directions.
These are actual roads in Calhoun, Georgia. Now it's your turn to show what you have learned.
Go.
Quiz time!
Go.
Are you accelerating on this curve?
Is there centripetal force, and if so, which direction is it coming from?
Which way will the car go if you let go of the string?
Do you think a smaller or larger curve will require more force?
Do you think the speed limit for a small or large curve will be the same?